So the cool thing about the NOAA satellites is we have a lot of capability. Not only can we warn you about the bad weather, but we can also tell you about the good weather as well. So everyone wants to see the spring coming through. Well, through our satellites, you actually have the ability to see spring actually coming through by the vegetation, by actual blooming. You can actually see it getting greener through the season. So NOAA satellites, we have actually two sets. We have a polar orbiting satellite. So if I use my hands as the globe, we have a polar orbiting set that actually pulls data from the planet, but actually pushes that information into the numerical models that forecasters use to actually forecast the conditions and weather. And then we also have the geostationary. So as we sit in geostationary sync, we can actually look at one spot on the globe for a continuous time frame. And it's from that benefit that we can actually watch weather move from east to west or from west to east. And as a result of that, we can watch entire systems develop and actually go through their entire evolution. So in the past 60 years, we've made tremendous advancements in the science of meteorology as well as with satellites. Satellites now have the ability, at least the current GOES series has the ability to see more information, 3 times more information than the previous series. We also have the ability to have 4 times the resolution. And what that provides forecasters now is a greater understanding of real-time development, which gives them a greater ability to provide forecasts for what's going to happen. And then for the climate monitoring perspective, we now have multiple channels, more channels in which we can see or interrogate the atmosphere and have a better understanding of what the atmosphere is doing over a longer and prolonged period of time. So NOAA is able to pull all that data from the satellites, both from the polar orbiters as well as the geostationary, into the numerical models in which forecasters use to give you your daily forecast. The same forecast that you use on the phone or that you'll see in your nightly news, all that information goes into those numerical models to provide you with high temperatures, winds, and when you can expect to see the winds be stronger or more importantly, when you can see the temperatures dropping off. So all that information goes into those daily forecasts. So the good news is with both satellites, with the polar orbiting as well as with the geostationary satellites, you can see all types of weathers, or in weather speak, all scales of weather. You can see the very large scale and the very small scale. Specifically with the geostationary, with the ability to see directly into one area, we can target one specific area for forecasters, and they can look at actual storms that will develop and move through a particular area. In the case of the Midwest, if you see a thunderstorm that's going to develop, they have the ability to task that satellite or request that satellite to look at that particular area for severe weather every 30 seconds. So they have near real-time capabilities to watch a storm mature and develop. And it's through that they have the ability to actually forecast and warn you on where to get out and if you have to actually take shelter. Well, satellites have come a long way, but right now where they have become is actually an essential tool for emergency managers to manage the message on when people need to both get out and to get away, or even to stay put because of severe weather that can be moving into the area. That information goes directly into operations centers. More importantly, it goes directly into the forecasters that provide that forecast to those emergency managers to provide you with that message, whether it's going to be shelter in place or that you need to evacuate. So the question is, how different would the world be without satellites? Well, again, we would actually be blind. Without the ability to forecast, we wouldn't know conditions as they're going to develop, or more importantly, how they would impact us over the next day, 2 days, or even the next couple of weeks. Now we have the capability to look at our atmosphere and look at the conditions and actually forecast for those conditions over at least a 3 to 7 day period with good confidence. So how did the NOAA satellites work together in providing us with a forecast? Well, the polar satellites, as they rotate over the Earth, they actually are providing atmospheric data that goes directly into the models. And it's with those models that forecasters provide you with that forecast, whether it's the 12-day, 3-day, or the next 24-hour forecast. The geostationary satellite, however, it has the ability to watch at one specific spot of the globe and watch systems develop and move through. So it provides near real-time capability for forecasters to see how conditions will develop, and more importantly, how those storms will move through the area. So the coolest thing about our new satellite for the GOES satellite is that we have a lightning mapper on board, and that lightning mapper looks at one specific spot, specifically when thunderstorms are developing, and it gives us an idea of the intensification of that lightning. And lightning and its activity is a key indicator for forecasters to know how strong the storm is, more importantly, where it is within its life and how soon it will actually die off.